Welcome, amazing friends, and let's look at this question on circle. I tell you, this question is very simple, okay? If you know what to do, kindly let us know your thoughts in the comments. But before you do that, let's read the question together. We are told in the diagram A, B, C, and D are points on the circumference of a circle. Don't worry, I'm going to explain each term step by step, okay? Now, when you talk about circumference, it means you have a circle. And when you have a circle, the outer part of this circle is what we call the circumference. Now, carefully look at this diagram. We are told that these points are on the circumference. So we have, this is A here, this is point B, here is C, and here is D. What did you observe? You see that these 4 points are on the circumference of this circle. I hope that one is clear now. Now let's get to the next statement. The next one says xy is a tangent at point A. Now, what do we mean by tangent? Tangent is just that straight line that touches the circumference at a point. It does not cut through, okay? It won't cut through, rather it touches it at a point, and we call this one a tangent. But note, it's different from when you have this cutting through. It cuts through at 2 points. When you have this one drawn this way, we call this the secant. I hope you got the difference now. Now, go to the diagram again. Where do we have? We said xy. Look at your x and look at your y. You notice it's a straight line, and it is at this point A where it touches the circumference that is the tangent. I hope you have understood it. Now, what did the question say we should answer? We are to find the value of, this means angle CAX. That means the angle will be on the center. Did you see that? So when you have something written this way, the angle is on the center letter. So to answer this, let's go back. We are looking for angle CAX. This is C, this is A, and this is X. So which angle are we looking for? Angle at A, which is this angle. Did you see it? So how do we get this angle? That is the question. If you know what to do, you can still do it, but let me show you the easiest way. Now, when you have this kind of question, please remember your circle theorem. It gives you a guide to know the step to take for each question. But remember, all the information you need to answer this are here. The only thing you need to do is to remember your theorems. And if you want to know more about those theorems, I will leave a link in the comments. Now, let's still take them one at a time. Now, to answer this, is it possible we get this angle? Just watch. Can we get this angle here? And if we get it, it will be of use to us? Let's still see to that. If we can get this angle here, you know we have been given this one as 60. Just watch that diagram. Let me bring it out. Just watch. I hope you can see what we have there. And there is a line here. And this is C, this is X, this is your A, and this is X. Did you see that? And you know here has been given as 60 degrees. Did you see it? So we are asking, if we get this angle here, can it help us to get the one we are looking for? That is the question. The answer is yes. And let me show you what you do. So what you need to do is, to get this angle at C, go back to the diagram. Remember a theorem which says that when you have a circle, this is a circle, and this circle, when we talk about circle, there's something we call arc. This is an arc. An arc is a part of a circle. So if I decide to choose an arc on this circle, and this arc here, this arc, decide to make an angle with the chord, there is something we call chord. When you talk about chord, this is your circle. And if you talk about chord, a line runs from the circumference to the other, but does not cut through and will not pass through the center. We call this kind of line a chord. I hope you are seeing it. Now, when it chooses to pass through the center, it is no longer a chord. We call it a diameter. Did you see this now? Now, when you have this arc, you notice that the angle this arc makes with the chord and this chord here joined, did you see it? The angle this arc is making on the circumference with these two arcs, with these two chords, is the same as the angle the same arc makes on another point of the circumference. in the same segment. Did you see that? So we have this. So we have this. So this angle here and this angle here are always equal, provided they are made by the same arc. And what theorem does this obey? It obeys what? Angles in the same segment. Did you see that? So angle in the same segment says that the angle formed here and here by the same arc unbounded by chords are always equal. So can it help us to get what we want? Let's see to that. Now, when you look at this diagram, watch. You will notice that this arc, this is the arc. Did you see the arc? Did you see it is a part of the circumference? And this arc is our arc AB. You see that this arc here, just keep watching. It made an angle. This is a chord. Did you see it? I hope you are seeing it. Did you see? So this arc made an angle on the circumference. And the same arc AB, watch, keep watching, also made another one. Just watch. Did you see it? It made another one on the circumference by the same arc obeying this. So what does it mean? It means that this angle here should be equal to this angle 20. So we are going to still label here angle 20 degrees. So what it means is that we have gotten here to be 20. But what is your reason? Because you need to back it up with reason. Your reason is that, so we can say that angle A, so we're going to name it angle ACB. That means angle at C. So we are going to have it that, so we have it that angle ACB is equal to what? 20 degrees. Our reason is angles in the same segment. Now, having understood this, what other thing do we need to do? You have seen that we have gotten this angle and we know this. So how do we now find the one we are looking for? It's just very simple. You will notice that this main diagram here is a diagram of a triangle. And if it's a diagram of a triangle, it should remind you of something that should help you to get this. And let me help you to remember it. You know that the angle that these two angles make, these two angles, the angle they form here, when you add them together, just watch. If you add these two angles together, it should be equal to the one in the exterior. What do we call it? We say that, just watch, if you have a diagram drawn, a triangle, where you have this, these are the interior and the interior opposites. So the angle they form here, according to your theorem, when you add it together, it gives you the angle here. So here will be A plus A. Supposing this is B degrees and this one is B degrees. So when you add these two, it gives you what should be here. And what is that theorem called? It is called the exterior angle. This is angle is equal to two interior opposite angle. I hope you are seeing it. So this is another theorem that will back it up here. So in that case, you will now see that when I add these two together, it's going to give me what should be here. So what do you call it? You can now say that angle CA, so we have angle CAX is equal to CAX, which is this angle, is the sum of these two. Okay? So we are going to have, add it, you are going to have 20 plus 60 degrees, and that will give us 80 degrees, obeying this rule. And what is your reason for that? Our reason is what? Angles in the same. So our reason for this is exterior angle is equal to 2 interior, is equal to the sum, let's make it clearer, is equal to the sum of 2 interior opposite angles. I hope you have seen the reason. Remember, this is our A, so let's get to B. Now to answer the B, we are told find angle ABY. Angle ABY is angle at B. Go to the diagram. This is A, this is B, this is Y. So it means you are looking for this angle. So let's just bring that diagram out. This angle here is our 60, which is angle at Y. This is the one we are looking for. And this is angle A. There are a lot of things you can do. Let me ask you, can we get this angle at A? You know, if you get this angle at A, it will help us to get angle at B. You can just brainstorm on that And let me show you another way you can answer that. Now, another thing you can still do is, remember that this is a straight line. Watch. This is a straight line. So, can you get the value of this angle? Just watch. Is it possible for you to get the value of this angle? And if you get it, what will you do with it? If you get this angle, you will notice that it is angle on a straight line. Did you see that? Where here is B, and there is a line separating it. So if you get this angle here, you know it will help us to get this one we are looking for. That's another way you can do it. So our target will be on how to find this angle, and we are choosing to find this angle instead of this one at A because we already have something that will help us. I hope you are getting it now. So to answer this, let me show you what you do. Remember that an angle has been made here, an angle at A, which we have said is 80 degrees from our first question. So if this angle is 80, remember a theorem. And what does that theorem say? The theorem says that, let me bring it down. The theorem says that when you have a circle and there is a tangent, what happens? The chord, if a chord comes in contact with the tangent, the angle that chord makes with the tangent, watch, the angle the chord makes with the tangent is equal to the angle in the alternate segment. What does this big grammar means? It means if this angle here is A, this is your tangent, this is your chord, the angle they make at the point of intersection is equal to the angle in the opposite segment. So in the alternate segment, sorry. So what it means is that what you have here should be equal to what is here. I hope you have seen it. This is true. And if you watch this side, this is also a chord, and this is what? A tangent. So you see, the angle they make at the point of intersection, if you call it angle B, it should be equal to this one here. I hope you have seen it. So here we should be degrees also. So this angle is called, this is a tangent, as we've seen, and this is a chord. So you see they both make an angle 80. So it should be equal to the one in the opposite segment, in the alternate segment. Did you see it? So you see it's obeying this. So it means that if here is 80, this angle made here will also be 80 degrees. And what is our reason? So what are we going to label it? We are going to say that CBA. You see, that's the labeling that covers this angle. So we have it, angle CBA is going to give us 80 degrees. Our reason is the tangents and alternate segment angles. I hope this is clear. So now that we have gotten that, what do? It makes it much easier for us to get this angle. And to get it, remember, it's on a straight line. An angle on a straight line sums to 180. So if that is the case, what do you do to get this angle? It means that the angle we are looking for, which is angle ABY, so we conclude that angle ABY is equal to 180 minus this one we have. Because if you have this and add it with this, it gives you 180. So take this away from 180, we are going to have 100 degrees. Our reason is what? Angle on a straight line. So we're having our reason angle on a straight line. I hope this is clear. So we have seen that in conclusion, our angle for ABY is 100 degrees. And I hope you learned a lot of skills. Help us to share this so that more people will learn this, especially those that have this as a challenge. Subscribing for us will help you get more tips from us, and give this tutorial a thumbs up. Remember to tell us how helpful it is in the comments. It helps us to serve you best. I will see you in our next class to discuss more. Till then, bye-bye.